So in this example problem, we're asked to solve for our strains epsilon z and gamma zx. All right, and we're given the elastic properties of our system um, as being 10 mega psi, and our Poisson's ratio as being 0.3, and we're given our stress matrix. Okay, so the first thing we just need to do is we just need to get our equations. Okay, so we need the equation for epsilon z and the equation for gamma zx. So we can go back in our lecture packet and we can search out for those equations. All right, so here is our equation for gamma zx, and here is our equation for uh, epsilon z. So if we just copy those two equations, alright, I'm being very lazy using the snipping tool here. Alright, and we'll just paste those in. Alright, and then we can just plug in our numbers, and we'll try to solve for epsilon z and epsilon x. So epsilon z will just be equal to 1 over 10 mpsi times, so let's write everything in terms of in its base units. So we'll do 10 times 10 to the sixth psi, and then we'll put in sigma z, which is equal to 4 times 10 to the third psi minus 0.3 times sigma x plus sigma y, which is going to be equal to 5 plus negative 1 times 10 to the third psi. If we put all that in, alright, what we'll end up getting is we'll get epsilon z is going to be equal to 280 times 10 to the minus 6 inches per inch for the strain. Alright, and then for gamma yz, alright, or um, for gamma zx, I should say, alright, what we're going to get is we're going to get, use this equation, so we'll get 2 times 1 plus 0.3 divided by 10 times 10 to the 10 to the sixth psi, and then we're going to multiply that by tau zx. So tau zx is equal to 2 times 10 to the 3 psi. Alright, so if we multiply all that out, what we end up getting is we're going to get 5.2 times 10 to the minus 4 radians. Okay, so which is so if you multiply that by pi radians for 180 degrees, you can get the shear strain in terms of an angle. So that's going to be equal to the same thing as 0.03 degrees. All right, so the shear strain in this case is very small angle, and the shear strain is also very small. All right, so um, so that concludes how you could solve, if you're given a stress matrix and the elastic properties, how you can solve for any strain, either a normal strain or a shear strain, using the stress strain relationships we developed in the last two lectures.